Welcome all. Today we will have an overview on field programmable gate array. So FPGAs are ICs that contain an array of identical logical block with programmable interconnect. The user can program the function realized by each logic block and connection between the blocks. The FPGAs have revolutionized the way of prototyping and designing. So these two words are important. Suppose if you want to so this is the logic function you want to realize. So what you will do normally, you will go to shop and get AND gates, 3 input type AND gate. So 7411, this is 7411, and this could be 7408, and these are nothing but OR gates, so it is 7432. This is the way we usually build logical equations. But using this FPGA, you don't have to go to electronic shop and buy AND gates and OR gates. What you have to do is, you will have to write the thing which is called hardware description language, where you are going to describe the connection you are going to give in hardware description language in 3 types of levels. So gate level, data flow level, and behavioral level, and you convert this into bit form and transfer to the FPGA, and this bit form will configure what is the connection you need in the FPGA. So this prototyping and designing means, this is the meaning of prototyping and designing. So you don't have to buy your AND gates and OR gates. What you do is, you describe all your logical function using hardware description language, using 3 levels of modeling like gate level, data flow level, and behavioral level, and you convert it into bit form using synthesizer, and then you using implementation, you send this bit file into the FPGA and see the output. So the flexibility offered by reprogramming FPGAs have enhanced the design process. So you can reprogram it again and again. So it is not meant for realizing this function alone. You can reprogram it as many times you need. So that is the benefit of going to FPGAs. So if you go to organization of FPGA, it has 3 important functions. The first function is called programming logic block. So this could be done using LUTs, muxes, etc. Programming inputs and output blocks, and programming routing resource. These are the 3 important resources present in your FPGA, so that you can prototype and design your system as you wish. This is the layout of FPGA. This is nothing but programmable IO block, which is going to be present in your periphery or in the edges of the chip. So the array of programmable logic blocks are distributed within the FPGA. So this is the array of programming blocks present in FPGA. So this is considered to be an array of logic blocks. So this is nothing but logic block are being present inside the FPGA, and it is programmable. Programmable in the sense, inside this logic block, you could use, or you can adapt what is called as LUT or MUX, whatever technology you need. So whatever technology you need, in the sense, when you buy an FPGA, you should select a particular family or thing where these LUTs or MUX will be present. The logic blocks are surrounded by input output interface blocks. So this is the programmable input-output block which is present at the edges. So I/O blocks can be considered to be on the periphery of the chip. Periphery in the sense it is going to be present on the outer edges of the chip. So these I/O blocks are being used to connect the logical signals to the FPGA input. That is the function of I/O blocks. The space between the logic block is used to route connection between logic blocks. So these spaces. So when you consider these spaces are required for making interconnection. Suppose we are working with LUT. Our programmable block is nothing but LUT. So this is 4 variable and this is also 4 variable because we have 4 inputs. And you can realize logical function. So suppose if your logical function requires 2 logic blocks where LUTs are 4 variable. So these 2 LUTs have been used. So the routing has to be done between these 2 LUTs. The routing has to be done within these 2 LUTs. So these spaces in between these LUTs or in between the logic blocks is used for giving interconnection or routing procedures. So the programmable logic blocks are created by multiplexer, lookup table, and or in the sense it is going to be AND is going to give minterms and OR is going to get the output in the form of SOP form, and NAND arrays or NAND, you know, NAND gate is a universal gate. So using this NAND gates you can realize logical functions. So the overall, the programming, that means changing the input and control signal of the multiplexer. So the first point defines about logic block. So programming, that means changing the input and control signal of the multiplexer, changing the lookup table content or selecting or not selecting particular gates in the AND or gate, that is selecting a particular minterm and rejecting all other minterms to get your required logical function in SOP form. The second point is for programmable interconnects. Programming means making or breaking specific connection. This is required to interconnect various blocks in the chip, that is in between 2 blocks. You need a connection, then you have to program this. So it is programmable interconnect. So this is LB and this is also logical block. And third is programmable I/O block, denote block that can be programmed to be input, output and bidirectional. It means suppose if this is going to act as input, or I want this pin to be output, or if I want this pin to act as both input and output, that is called bidirectional. These things can be programmed in FPGA. So these are all the benefits of working with FPGA, and main thing is for prototyping and designing, these FPGAs have been used. And thank you all. Thank you.